Before you can start using the Geogebra question type, you first need to make sure that you have Geogebra installed on your system. So here I have choose a question type. So I went and created a new question, and out of the list is of course Geogebra. Alright, so then you would add, and you can go through the process, and I'll show you that later. So you have to go to Moodle.org plugins qtype / Geogebra. It'll bring you to this page. You can also do a Google search on Geogebra question type, and it'll eventually come up to the Moodle.org website. The second thing you need, of course, is the program Geogebra. Otherwise, this isn't going to work really well. And generally what I do is I set it to a grid, I fix it, I make sure that the graphics are fixed square, and then I change my distance on the x-axis and y-axis to 2. That way it just numbers every 2 spots. And then for the grid itself, I want it 1 by 1. And I normally do things that are fixed on a grid, and if it needs halves, you can put in halves and stuff like that. So that's just my basic setup. The size of the window you have here is what's going to show up in Moodle later on, minus, of course, the algebra column here. Sometimes I add on a second window. Let's see here, where is it? I'll do the graphics too, and I'll get rid of the grid completely, and I'll add in probably the problem in here. There's a way of doing it in the question itself, but I find using the textability of Geogebra is much nicer, especially dealing with fractions and whatnot. Alright, so let's say I'm going to design a question that asks a student to graph a line. So the first thing I would do is I would generate just 2 random points, A and B, and of course the line that goes between them. So this is what they would see. And I normally change everything to blue, it's just a color. So the students would have this, and they would be able to graph the line and put these points in any 2 locations on here and have a line drawn. I'm going to restrict it so that A or B has to be on the y-axis, the y-intercept. Alright, so in the background, I also need to have the equation of the line that I'm asking them to graph. So what I usually start with is 1/2, 1/3, 2/3, 1/4. Actually, let's stick with thirds. 2/3, 4/3, 5/3. That should be good enough, and so forth and so on. And then I'll change the sign using a different thing. So here I have a list, 1, 2, 3, 4, 5 elements long. So I'm going to let n equal a slider, 1 to 5 by 1. Alright, and these are what randomize the question. So when I want to pick out a slope, I will do the command for the list. So it'll be slope n. Whoops, illegal argument. Oh, I call it slope 1. There we go. Slope 1n. And that'll give it the 0.5. So as I move it, the slope value is going to change through all the numbers that I had. Alright, now after having that slope list, I want to create part of the text structure. So I like using what's it called? Fractional text of slope A. And what that'll allow me to do is to write the question where I want it to be. So here you'll notice it would put a 1/2 here for the first slope, 1/3, 2/3, 4/3, and 5/3. Alright, so that'll at least give me the number of the slope for my formula. Alright, so I also want to be able to go back and forth between a positive slope and a negative slope. So I'm going to do sine slope. And I'm going to do a slider for that one, -1 to 1, and I want it to step by 2. So it just bounces back and forth between -1 and 1. It always goes to 0, so you might want to, just at least move it around a bit. And eventually I'm going to hide these. All right, so we also want to have the negative sign so we can go with the 1/2. So we want to do an if statement. If sine slope is equivalent equal to 1, then we want the plus sign. Sine slope, well, this one we don't need a second condition. If it's not positive, it's definitely negative. Certain ones you want to separate into less than, greater than, or equal to, and have 3 different possible conditions. Alright, so enter. Invalid. Why is it invalid? Equivalent. There we go. So equals is one thing, equivalent is a logical argument. So now we can put the text as -1/2. It's not going to float where I want it to, but at least I have it available. The next character I need is the y-intercept. So intercept. This one I'm just going to make a slider that can go anywhere. So let's say -5 to 5 by 1s. We can also just call it b, which would make life a lot easier. b equals that. And actually we could probably go back and change slope a into m if we wish. Alright, so again I'm going to move b off of this. Alright, so now we have the slope as a fraction, the sign of the slope, intercept. So let's let b just be a slider that runs -5 to 5 by 1s. So it'll just range up and down the y-axis a little bit. And later we're going to need b the number and b the sign, or if b is equal to 0 we don't want it to show up at all. So one way of dealing with that is first we'll just get b the number, the value of it, absolute value of b. The system called it a. You can give it a specific name too. I usually call it abs b or something silly like that. Then we need the sign of it, so if, and I'll give this one a specific name, sign b. Alright, so if b is not equal, or I'm sorry, is greater than 0, then we want to have a plus sign show up. If b is less than 0, we want a minus sign to show up. And if b is equivalent to 0, we don't want anything to show up. So we'll type that all in. Alright, so right now it's plus. We also want to make sure that b shows up only if it's, has a value. So let's work with the a, because I might as well stick to it. So, do we have a big B listed yet? Oh, B is a point, so I can't use that. So let's say B1 is equal to if A is not equal, so that's an explanation with an equal sign, 0, then what I want to show up is A itself, or text A. I guess it really doesn't matter, but I better go with text A. Because later I'm going to have an empty space and that goes as a text string. So if A is equivalent to 0, then I don't want anything showing up. Alright. So that'll give me the sign of the slope, the sign of the y-intercept, the y-intercept. So now I can start creating what the question is going to look like. So I'm going to choose text. I'm going to try to put it over here. I might have to move it later. I'll probably be safer here. Let me cancel. Let me just put it here for now. And then I'll move it over into graphics to forcefully. I'll turn on latex. First thing I always do is put small directions here. I'll use the Moodle to put in larger directions, like one of the points has to be on has to be one of the y-intercept. Has to be the y-intercept. All right, so I want to graph the line, a couple spaces, carriage return, the 2 slashes is carriage return in LaTeX. And I want to have y equals. So now I'm going to go into my objects. I guess I could pick them off to the side, but I like doing it this way too. So first off, the sine of the slope, then the slope x, the sine of b, where sine of b, and then I want b1. Alright, and then say OK. Oh, cancel. Go back to a pointer, click on this, mouse click, object. I want it in graphics 2. Okay. So where did it disappear to? Ah, there it is, way up there. Drag it down, shrink my window back up. Generally, I like making it a little bigger, so medium, bold if you want, but it messes up the LaTeX a little bit. I'll do blue, and that should be it for that side. So I can shrink that down right onto the box, and that's kind of what it'll look like. Eventually I'm going to get rid of this side, so I'll have to resize things before I go. So let's test this out. If I make it go through the N, which is changing the slopes, I get all the slopes I've chosen, and I can make the list longer. I mean, you can include almost anything. I can change the sign of the slope, and I really should get rid of that plus, because normally you don't write it that way. So I'm going to go back to the sign of the slope here. I'm going to get rid of plus and just let it be empty space. And we'll get down to that. Alright, so sign of the slope negative, and then as b becomes positive and or negative and 0, I like that because it disappears and you just have the 1/2 x. Now a couple things you have to turn off. You got to turn off most of the text over here. The sign of b, b1, text 1, text 2. You've got to leave text 3, that's this one over here. But the rest of them show up here somewhere near the middle, and if you leave them it just looks weird. I'm going to turn off my sliders. I don't need them anymore because I played around with it. And now I can create a few other things. So I'm going to create, what should I call it? M, capital M, equals sine slope times slope A. And that way I have a number to compare to the slope of the line I'm going to come up here. Alright, so this is the equation of the line that the computer is looking for. So what I want to do is make sure that it works. I'm going to put my line right on top of it. And I'm going to come up with the possibilities. So I usually call them correct 1, correct 2, so forth. So COR1 is equal to. Now I want to make sure that A or B is definitely on the y-intercept. So I'm going to say x of point A is the same thing, or I'm sorry, yeah, is the same thing as 0, or, that's double slash bar, x of B is the same thing as 0. So this is true now, but if I move the A to here, it's the same line. It became false now. So one of the points has to be the y-intercept of the graph, and it doesn't matter which one it is. Here I force B to be the y-intercept. For my correct 2 here, I'm going to say that f is the same thing as g. And again, it says it's true because my line is right on top of it. If I moved it up 1, they're parallel, but now it becomes false. Alright, and to correct 3 is equal to correct 1 is the same thing as true, and correct 2 is the same thing as true. I like that one because then it would say, you know, your point's in the right location, your line is exactly the same, and here this would be all, the whole graph is right. So what I'm going to also add in is a wrong, and that's if correct 3 is equivalent to false. And then I usually go through and give them their captions. So Moodle's going to look at the captions of each one of these true-false statements and assign grades to them. So correct one, you plotted... Ooh, I'm going to have to add in one more thing in there. Y-intercept correctly. You have to click out of the box, otherwise it doesn't save. Correct 2, line is correct or right. And correct 3, graph is correct. And then the wrong would be at least one part is incorrect or wrong. Okay, so the piece I need to add up to correct 1 is, sure, x is, I have a y-intercept, but I also want to make sure it's the right y-intercept. So, and y of a is equivalent to, what did I call it, b, or y of b is equivalent to b. So I probably should put these together. Let's see here, this piece here, x, put it with him. So sure, it's on there, but it's also in the right location. I'm going to put parentheses around this. It'll take them away if I don't need them. And let's do the same thing for this one. So x is on the y-axis, and I want it to be specifically the y-intercept, and then end the parentheses. All right, that's a little bit more inclusive. See if they took them all away. It should work out, so let's find out. All right, so b is still on the y-intercept. So it all became false and our wrong became true. So once b touches the y-intercept, it became true. So before, it would have just been anywhere on the y-axis and it would have been true. So I've kind of fixed that little error. And there we go. So everything's true except for the wrong part. All right, so I'm going to save this file. Ooh, before I do that, view algebra, I have to turn off a few things. Number one, the question line. I don't like them naming them, so I'll hide that. I want to leave A and B because that's going to be part of my directions. All right, so now get rid of this, size it a little bit, center it. All right, so save it. Oh, it's going, there it goes. Let's put it, put it with my other GeoGebra graphs. Test line. Okay, save. Alright, and then we're going to go to Moodle. Alright, so I'm going to create a new question. It is going to be one of the options, and I'm going to say add. Alright, I'm going to give it a, title, and in here I'm going to say graph the line below and be sure that you plot the y-intercept. And I could probably say something like use A and B to plot the line. You know, you can get really specific. So down here I want to put in my file, so I want to say drag and drop, and I want to go get my file, and I'm going to just drop it. The whole thing turns gray, so you can just drop it anywhere you want in there. We want, it's taking a while, there we go. we want variables, and the variables we have are n, that's the counter that picks the slope. Sine slope gives you the sine of the slope, and b, of course, is your y-intercept. So those are the three variables I definitely want to be randomized. And then down here, notice it has correct 1, correct 2, correct 3, and wrong. If you have more of them, you can add more blanks, put the name in here. When you save it the first time, it'll pull the feedback line. And these things are what shows up at the bottom of the graph when you do it. So normally, the intercept, let's say it's 25% of your grade, and most students don't even care if they get it wrong. They want to retry the question. And the graph is correct. Let's say that's, 50% of the grade. So that's 100, and you don't want anything for the wrong. You don't want to penalize them or anything like that. I like doing multiple tries. You can change this to anything you want. 0 is usually alright by me. If you do the point reduction, again, my students, even if you take 20% off for one try again, they'll go and redo the whole thing so they can get 100. Alright, so I'm going to save changes and test it out. Must be a mistake. No? Okay, preview. No mistakes. A little bigger. One nice thing is the students can drag the graph around, so if it doesn't fit the general information, they can move it. They can scale it if they do shift scroll. So they can get it in the right location. Ooh, I didn't want to scale him. So here's what I want to graph, and I'd let this float so they can move it around. Alright, so I want to graph 2/3 x minus 1. So I'm going to go down 1, up 2 over 3. And that should be the line, and it should grade it correct. So let's get it wrong first. So let's hit check. So here it says you plotted the y-intercept correctly. At least one part is incorrect. Try again. And then down here, of course, is the try again button. Oops, it's still loading. Okay, must have registered the try again. Alright, so let's get it right this time. I was 1 off, so up 2 over 3. Is there something? Oh, that's just the 0. Alright, and then hit check. And what? Oh, there it is. So you plotted the y-intercept correctly, the line is correct, the graph is correct. So that means all parts, and the second time around we only got 80% of the grade because we took 20% off for the first attempt. So that's all there is to setting up a GeoGebra question.